Hello guys, in this video I will explain you about my recent project, that is social media ad classification project. And first of all, thanks to New B Technologies for giving me this project. So they provided me this dataset link, and then I downloaded this dataset here. And now let's start our notebook. So I created this notebook. First, I imported all required libraries. After that, we import our CSV file. Then I printed, you can say, some values or some rows of our data frame. Here you can see we have user ID column, gender column, age column, estimated salary column, and purchase column. Here, purchase column is our target variable, and all these are our independent variables, or you can say feature variables. So first we check what's the shape of our data set. Here you can see it is around 400, 5. It means it has 5 columns and 400 rows. So first we check if our there is an null value or not, and if there is a null value, we will fix this. So if here you can see we do not have any null values. After that, we will see if there are any duplicate values or not. And if there is any duplicate value, we will drop that duplicate value. We will drop that duplicate value using df dot drop duplicates command and save that in df column. For saving that in df column, we will do in place is equal to true. Then again we will do df dot shape. So we get 400, 5, which is exactly the same. So there is no duplicate value in this, you can say, in this data frame. So after that, here you can see inside gender column, we have categorical values, and also in purchase column, we have a categorical value, or you can say, now we will try to see what are unique values inside purchase column and gender column. For that, we will do df of gender dot unique. So we get two values, that is one is male and another is female. Same we do with the purchase column, df purchase dot unique. Here you can see we get two values, 0 and 1. So here 0 means that the person do not purchase the item, and 1 means that yes, he or she purchases the item using social media ad. So if you can see, we have a user ID column which is useless for us. So we are trying to drop this column from our data frame. We use df.data, df.drop user ID, comma x is equal to 1. Here x is equal to 1 means that it is a you can say column name. So and save this in df data frame. For that we will use in place is equal to true. Then we will you can see here our user ID column is gone. So now we will come to our visualization part. First we do df of gender dot value count, so we can found how many male and female are present in our data frame. Here you can see male are around 196 and female are around 204. So it is a, you can say, a balanced type data. Now we created gender distribution. So for that we created two plots, one for a gender distribution in data set and another is distribution of gender by purchase. Here you can see we just visualize this data. Here you can see it is 196 for male and for female it is around 204. So our data set is you can say balanced. So now what we do in this, you can say, in this visualization, distribution of gender by purchase, we created who. Here you can see we created a who is equal to gender. Sorry, yes, we created who is equal to gender. For a green part, it is for male, and for pink, it is for female. Here you can see there is slightly gap, or you can say more female purchased items from social media as compared to males. So next we will do age distribution. Here you can see we draw a histogram, and after that we created a smooth line. We displayed a smooth line here. Here the bin size is 10. So here you can see we give data is equal to df, our data frame, and then x is equal to age, and bins is equal to 10. And for creating this smooth line, we have to give kde is equal to true, and x is equal to axis. Here you can see. Then we set the title, distribution of age, and then plt.show. We get our visualization. Here you can see this is following the Gaussian distribution, which is a good thing for us. So again, now we draw to another distribution. One is distribution of age by purchase, and another is distribution of age by gender. So in first distribution, we do SNS dot box plot. Here we give x-axis as our purchased column, and y-axis as our age column, and our data is DF. And this palette is nothing but it is for just color theme, you can say. Then give we created here subplot where 1 comma 2. So we want to create two plots. That's why we give 1 comma 2. So here we defined x is equal to 0. It means we want to save, we want to place this graph inside our first place, and then we give the x label, y label, and title. For this, you can say x is 0. And now we created our second box plot. We created here x is equal to x is equal to gender, and y is equal to age, data is equal to df, and x is equal to, this time it is x is 1, this one. So now we set x label and y label and title. For x is equal to 1. So here you can see there is from this visualization we can conclude, uh, we can see people with higher age, or you can say elder people, are purchasing more items from the ad, from seeing social media ads. And here you can see there is a distribution of females, in age distribution of females, it is scattered more data as compared to male. So then we created our estimated salary distribution. Here we created again a histogram with a smooth line. Uh, so next we created distribution of estimated salary by gender, and distribution of estimated salary by purchase. So here you can see there is a high, you can say high, or you can say large deviation in our data set, that people from, you can say, less, uh, this is for 25 percentile, and this is for 75 percentile. You can see the data is quite, you can say, deviated, or you can say there is a high standard deviation inside this, you can say, purchase equal to 1 column as compared to 0. And people with, you can say, higher salary are purchasing more from social media ads as compared to people with less salary. So now what we do this in graph, we created correlation between age and estimated column. And here first we created a new data frame named not purchased, where we selected all the values where df purchase is equal to 0, and then created a second data frame, that is purchased, where df purchase is equal to 1. Then we created a scatter plot. Here we give the value purchase, using data frame purchased, we do age, and give estimated salary. Here we give color as blue and marker as star and label as purchase because this is from purchase data frame. Then we created another scatter plot, then a plt.scatter. Here we selected the note purchase age column and selected note purchase estimated salary column. Here we give the color, it is as red, and then marker as O, or you can say 0, then label it as not purchase, then give X label, Y label, and title to this. And also we have to write plt dot legend for this creating this legend. So we do plt dot show. Here you can see we find here you can see we there is no correlation between age and estimated column because this whole thing is scattered. But you can see here we can create you can say a line, or you can say split of people who purchase the item and who do not purchase the item. We can draw a line like this, so we can distinguish this age and sorry, not age. We can distinguish purchase is equal to 0 and purchase is equal to 1. Uh, so for what we do, so now we will convert our categorical variable, that is gender, into numerical variable. For that we do one hot encoding. What we do, first we imported one hot encoding and typed space output is equal to false and drop is equal to first. It means it will drop my first column, and then we save that data into this mail data frame. What we defined in this mail data frame, we created a we created a data frame, and we give data as OHE, that is our one hot encoding dot fit transform our data df gender, and give this column as a name male. Here you can see the column name is male and we get our data. So here for one male is equal to true, and for 0 it is for female. Now what we are trying to do, now we will add this column to our data frame and remove this gender column. uh, just a second. We will remove this gender column, and in this place we will add a male column. So for that what we have to uh, we do a df of gender male is equal to, we give our data frame as male, and here we use the df dot drop method for dropping gender column, and give x is equal to 1 and place is equal to true. Df dot head, we get our, here you can see we get our data frame. Nice data. Now what we do, we find correlation between all variables, or you can say correlation between independent and dependent variables. So for that we use core is equal to df dot core, and we created a nice heat map using sns dot heat map. We give data of our correlation, and said annotation is equal to true, and plt dot title correlation heat map. Okay, plt dot show. Here you can see we get our nice heat map here. Here you can see our target variable is purchased, and all others are features. Here you can see we getting nice visualization here. You can see as compare as purchase in purchased, we are getting around 0% correlation of gender male column. No, it is not around 0. It is around 0.04. So what we can do, we can discuss it with our domain expert, and we can we can drop this you can say feature if it is not important. Uh, so what we will do now, we will take the two cases. I will train my model for you can say two condition. In one condition, I will take all these three column as independent variable, that is age, estimated salary, and in third one is gender, male. And in my second model, I will train my model for just age and estimated salary columns. If I got the maximum in which you can say model I get maximum accuracy, I will select that model, and we will carry forward with that model. So first selected all three columns. I took all three columns, that is age, estimated salary, and gender, male column. So I defined here independent variable. I defined that is a new x is equal to my df dot drop purchase comma x is equal to 1. We defined our independent variable. Now for dependent variable, we use y is equal to df of purchase. Here you can see this is our dependent variable. Now what we will do, we will split our data into training and testing set. So for that we will use train test split. We convert you splitted our data in x train, x test, y train, and y test, and use train test split. Here I give x comma y comma random state is equal to 10. This is not important, or you can say we can give random value to this. There is no need to give this value 10. So in this test size, we give this as our 0.2. It means our testing set size will be 20% and our training set size will be 80%. And we do stratify is equal to y. Stratify means I want to distribute my data, or you can say split my data in same ratio as it is in you can say y column. And so then after splitting our data, what we do, we will perform now feature scaling. For feature scaling, I do standardization, use standard scaler for my feature scaling. I define my standard scaler here, and then I fit my you can say I fit my x train on this. For that I used scalar dot fit transform. So first I fit this on X train, and then transformed X train into X trains scaled, and then we defined our model. Here I use multiple models, but I got you can say maximum accuracy using this SVM sport vector machine classifier model. So I defined CLS is equal to SVC CLS dot fit trained scaled comma y trained. Then I performed you can say feature scaling for my testing set. For that I used scalar dot transformed x test and saved this in x test scalar scaled variable. And then it's come the prediction part. I defined y pred is equal to cls dot pred x test scaled. So I predicted for x test scaled and save that prediction in y pred variable. So now we created confusion matrix to see how there is what's the recall and what's the you can say precision. Or you can so we created here heat map. First for confusion matrix, so what we do, cm is equal to confusion matrix. First we have to give a y true value, that is y test, and then we have to give our prediction value, that is y pred. Then for creating heat map, we do sns dot heat map cm comma annotation is equal to true. Then we give our title confusion matrix, and then plt dot show. Here we get our nice confusion matrix. Then we created our classification report. Similarly, like confusion matrix, we have to do classification report. Then first we have to give y true value, that is y test. Then we have to give our prediction value, y pred value. Here you can see we get 96% prediction precision and 93% 93% recall score, and our F1 score is also around 0.9340 and 0.8941, and accuracy is around 0.91. Now we will train our second model with columns age and estimated salary, not with gender male. Let's see. So here I again defined my you can say independent variable, or you can say capital X. In capital X, I dropped columns gender male and purchase column, and just get or you can say just remain with age and estimated salary column. So then I do X dot head for seeing this you can say my data frame. Then I splitted my training, and uh, in this time I do not need to you can say define my dependent variable, because I earlier defined this already defined this. So now it's come the again splitting my splitting my data into training and testing set, again using train test split, again perform the stand you can say feature scaling, or on X train and X test. Then we train our model using X train scaled and Y train. Uh, then we predicted using our new model, that is CLS1. Our previous one is our CLS, and this is CLS1. Then we again created confusion matrix and printed our classification report. Here you can see we getting our F1 score 0.94 and 0.90, and our accuracy is also increased, that is 0.93 as compared to our previous model. So we will select this model. We can see CLS is performing better as compared to CLS, or no, sorry, CLS1 is performing better as compared to CLS. So we will select this model. As for now, what's our aim? We want to download this, or you can say save this model. So for saving this model, what we have to do, we will use pickle with open model.pkl. Here we give our how we have to, or you can say what file name we have to give. Then we provided file name, that is I want to save this as model.pkl. Then give wb as f pickle.dump. Here I want to save my cls1 model, so I give here cls1 comma f. Now we will save our saving our scalar part, because when we create our web app, we need to do scaling, or you can say pre-processing. For that, we also need to save this scalar. So here, when we run this command, we get our this scalar.pkl and model.pkl. Now our this part is done. So now what we will do, we will create our Flask web application. So we will open this. For that, we created this app.py. This is our Flask web application. Here first we have to import our Flask render template, request and redirect and URL like libraries. Then also we need to import requests. Also we need to import numpy as np, and pickle for loading our scalar and model. So here we defined our app is equal to flask underscore underscore name underscore underscore, and then we loaded our scalar and model as scalar and model. So here this is our home page. When it we will you can say run home, then it will render index.html. Let me go to templates, and inside templates we have index.html. So here you can see this is our website. So we have our labels like age, age and estimated salary. Here we will you can say provide our age and estimated salary, and then we will, if we click on submit button, it will start predicting. Let me again open the When we hit our, you can say, submit button, this part of code will be, you can say, this command will be executed. So here we loaded our, you can say, age, and then we loaded our estimated salary column. Here we created a numpy array for age and estimated salary. Then we transformed, or you can say scaled, using scalar.transform, and then they saved into scaled variable. And then for prediction, we used our model.predict scaled, and we save this in prediction. So if our prediction is 0, then it will be that our output will be false, and if our prediction is, you can say, 1, then it will be true. So we will redirect this URL to output if our output is false or true. So if our output is true, then it will redirect to this HTML, and if our output is false, then it will redirect to this HTML. Let me show you what's inside true and true.html and false. Here you can see when we will, you can say, hit true.html, it we will show he or she will purchase product from ad. And when it is false, here you can see he or she will not purchase product from ad. So now also uh, I saved all the, you can say, libraries needed for running this web app in request or requirements.txt file. So now we go to our AWS console. Let's go. So now here we will do what we will do. We will create a. Let me do one thing. Let me run this app locally. Let me show you. So here my app is running. Here you can see. Let me give random value. Here you can see my web app is running. Now let me close my web app. For that I have to use Control C. So my web app is stopped. Now what we will do, we will upload, you can say, deploy this web app into our AWS EC2 instance. So let's go to our AWS console. Here go to EC2. Inside EC2, we have to go to instances. We have to click on launch instances. Now we will give this name as, you can say, it social media ad. Now we will select the image. I will select the Ubuntu image for this. Just a second. Here also I will select the very small machine, or you can say free tier eligible machine. For now we will create a new key pair for our instance social media ad. We will save our private key here, create private key. So our private key is downloaded here. Now we will launch our instance. It will take around 2 to 3 minutes for running. We go back to here. You can see a instance state is pending. After 1 or 2 minutes, it will go to running state. Also here we will take use of putty for making connection with our you can say with our instance. Let me go to putty. Let's see our web app is running or not. It is still pending. And so our for our web app we need app.py and this templates folder and model.pkl and scalar.pkl. So for you can say uploading this data to my instance, we need another software that is WinSCP. Let's see. We need this software. This is free, WinSCP. So what it will do, in one side we get our. We will run this later. Let's see. It is still in pending state. Till then, what we can do, we can create a new security group here. Let me. So in this security group, what we will do, we will give the complete or you can say full access to this security group. Also, let me give this full access. So anyone from you can say anyone from internet can connect through this app which we deploy on this instance. For this, we have to do our inbound rule as all traffic and IPv6. We have to just do this and create a new security group. Now, what we will do, we will you can say bound this security group with this our new instance that is social media ad. So here you can see it's come in running state. For now we will connect it with our you can say putty. So for connecting it with putty, what we need public IP address, we need username, and we need private key. You can see here we downloaded our private key that is social media .ppk. So let's go to our putty software. Here we have to give host name or IP address. We will copy from here and paste it here. After that, we have to go to connections. Connections inside data auto login username. Here we have to give Ubuntu. After that, we have to go to proxy and here we have to type Ubuntu. Then we have to go to SSH auth. In credentials, we have to browse our private key. Here you can see that is social media ad.ppk. Now let's see it will connect or not. Here you can see we are connected with our you can say our Ubuntu instance. So now let me do one more thing. Let me inbound you can say attach my security group with this. For attaching this, click on this, go to instance actions, go to change security groups. Here we will search our new security group that is full access. We will add our security group here and click on save. You can see after some time it will connected. Status checking, initializing. Okay. Now also what we will do. Uh, let me do one more thing. Let me connect with WinSCP. So here I create a new site My host name will be this public IP, and username is Ubuntu. We do not have password. We have our private key. For that, we have to go to advanced and find this authentication. Here you can see we will browse our private key file. Select this and click on OK. Now we will try to log in. Yes. So here you can see in my right hand side we have our you can say Ubuntu server, or you can say EC2 instance, and in my left side I have my local directory. So let me go to projects where we have our social media ad classification web app, that is Flask web app. Now what we will do, we will create a new directory. Give this as web app. Now just we have to do drag and drop. We want to transfer template. We also want to upload app.py. We also want to upload model.pkl, scalar.pkl. We can also upload requirements.txt and use this to install you can say libraries, but currently I'm not doing this. So let's go back to our putty. So now what we have to do, we have to do sudo apt get update. We will update our sudo you can say apt. Then we will here you can see, let me do one more thing. Let me show you. Here you can see I do ls, and here web app is constructed, or you can say there is no directory name web app. Let me change directory to web app and show you all these things are uploaded or not. Here you can see all things are successfully uploaded. Here you can see app.py, model.pkl, scalar.pkl, and templates directory. Now let me do one thing. We will install Python. For that we will use sudo apt install. What's the command? It is Python 3 pip. We have to give while. So we have to click OK. So now what we will do, we will install our you can say packages. First we install numpy. I will do numpy is equal to 1, give this basic version, because I created a web app on this you can say this numpy version. That's why I need this specific version or a higher version. Also I have to install you can say sklearn library. Scikit-learn is equal to 1.3.0. Also I need to install Flask app. Flask. So let's try to run our web app. I guess it should run app.py. Here you can see it is running, and it is running on 8080 port. So 4 you can say for checking, or you can say open our web app. We have to. So this is our you can say web public link. Let me paste it here, and our port name is 8080. Here you can see our web app is running. Let me do some prediction. Click on submit. Here you can see our web app is successfully running. So our end-to-end project is completed here. If you want to, we can also delete this instance, but I will do it later. Thanks for watching.